Hey everyone, welcome to my series on cloud computing, and today we are going to discuss security and encryption features in Amazon Web Services S3. If you've seen my previous videos, we have discussed how to create S3 buckets, how to upload objects, and how to enable versioning in those buckets or objects. So today we're going to discuss the security best practices and the various encryption methods that we have in S3 buckets. So let's start. Let's look at the security best practices one by one. The first practice that we follow is we need to ensure that the Amazon S3 buckets are not publicly accessible. What does that mean? Now, if you've seen my previous videos, we have discussed about how to make your buckets accessible public. But bucket owners need to be careful about how much the buckets are accessible public and to whom they are being accessible. Using the block public access feature of AWS S3, you can actually set up your access so that certain requests can be restricted for which the block public access is set up. So basically, when AWS S3 receives an access request for a bucket from an access point, AWS S3 basically checks if there is a block public access setting has been set up for that particular access point, and if it has been set up, in that case the access request is rejected. The next feature that we have is implement least privilege access. What does that mean? So when we are providing access to certain resources on AWS S3, we need to be careful about whom you are providing the access, what kind of access we are providing, and to what resource we are providing. We should always provide the minimum access that is required to perform a certain task, which will actually reduce the security risk. We can make use of bucket policies, user policies, access control lists, and service control policies in order to implement least privilege access. The next practice that we have is use IAM roles for applications and AWS services that require access to Amazon S3. Now, whenever a Amazon EC2 instance or AWS service makes a request for a AWS S3 resource, it needs to provide certain credentials, AWS credentials. Now, instead of having to store the credentials as a long-term basis on the application or on the EC2 instance, it's always better to create IAM roles. Now, these roles provide temporary access for that application or service that requires the access to the resource, and that reduces the security risk, right? So in case the credentials are compromised, that can have a huge business impact, but having IAM roles instead of long-term credentials reduces that security risk. The next practice that we have is to enable multi-factor authentication, MFA delete. MFA delete basically enforces multi-factor authentication while performing delete operation on S3 bucket objects. So MFA delete basically kind of mandates multi-factor authentication while you're performing either delete on a S3 bucket or even to change the versioning state of the bucket. So the user, in case, it's just a added layer of security in case the user's credentials are compromised. So the user needs to enter his credential as the first layer authentication, and as the second layer authentication, the user basically needs to enter the code which he receives on a approved MFA device. So that adds basically a two-layer authentication in case the user's credentials are compromised and he needs to, the user credentials are used to perform a delete of a object in the S3 bucket. The next practice that we have is to consider encryption of data at rest and enforce encryption of data in transit. Now, for encryption of data at rest, Amazon AWS S3 provides server-side encryption as well as client-side encryption. We're going to discuss encryption in detail, but for now we have multiple methods for encrypting data on a server side, and also S3 provides methods for encrypting data at the client side, where the encrypted data is then stored at the server. Now, for encryption of data in transit, we should use TLS encryption for data transmission in a secure manner so that anyone eavesdropping on the network traffic is not able to decipher the data. Similarly, we also have object lock versioning, cross-region replication, and VPC endpoints. These are the different practices that we need to follow from a security perspective while working on Amazon S3 buckets. If you go to the docs portal for AWS, you will find a detailed documentation on the security best practices for Amazon S3, where each of these points that we have just discussed in brief have been discussed in detail with proper examples. So just have a look at that. These are very important from a security standpoint. Now let's look at the different methods of server-side encryption in AWS S3. We have three different server-side encryption technologies. We have customer master keys stored in AWS KMS, or the key management system. We also call it SSE KMS. We have the AWS S3 managed keys, which is SSE S3, and we have the customer provided encryption keys, which is SSE C. Let's look at these one by one. So when we're using SSE KMS, the first option, we are actually encrypting the objects in the S3 bucket using a customer master key by AWS key management system, which governs the policies for that key. And that key is used to encrypt the object in the bucket. Now when using this technique, we can either use master keys which are managed by AWS KMS, or we can use master keys which are managed by the customer themselves. If you're using master keys which are managed by AWS KMS, then while implementing the encryption, AWS generates the master key and stores the master key in the KMS. But if you're using a customer managed master key, in that case we need to have the customer create the master key first before configuring the encryption, and when we configure the encryption, then the customer needs to provide the master key. The second method is AWS S3 managed keys. In this method, an object is encrypted using AES 256 encryption using a key generated by AWS, and then that key is again encrypted using a master key, and that master key is rotated by AWS S3. Now the difference between AWS S3 managed keys and CMK stored in AWS key management system is that there are additional benefits or charges which are provided by the first option, which is AWS key management system option. The third option that we have is customer provided encryption keys, or SSE-C. Using this option, AWS lets the customer manage the keys while AWS just manages the encryption and decryption. So the customer manages the keys which are used for the encryption or decryption, and it provides the key while accessing the resource, and AWS takes care of encrypting or decrypting that resource and while using the key that is provided by the customer. So these are the three different server-side encryption techniques that are used by AWS S3. Now once again, I would ask you to refer to the doc site for AWS, and which you'll find a detailed documentation for all these different server-side encryption techniques or client-side encryption techniques that we have just discussed. And you will find a detailed documentation of how to implement, how to use these methodologies. So today we discussed in brief about the security best practices and the encryption techniques that are used in Amazon Web Services S3. Hope this was useful. Please let me know in the comment section, and if you face any issues, feel free to post a comment. Thank you.